A string of length 5 meter is extended by 0.04 meter when a load of 0.8 kg is suspended at the end. How far will it extend if a force of 16 Newton is applied? Alright, let's get things done. A string of length, that means original length, that's what we're talking about there, L0 is 5 meter, extended by, that's the extension, by 0.04 meter. When a load in this case is represented in terms of mass, 0.8 kg, in which if you want to turn it to weight, it means that the weight of that load will be what? 0.8 times 10. Weight is mass times acceleration due to gravity, and acceleration due to gravity here is 10 meter per second squared. So if you multiply that, you have 8 Newton. Okay, so how far will it extend if a new force of 16 Newton is applied to it? So even without solving this thing, I'll know that this thing will double, because you see, if the initial force was 8 Newton and it extended by 0.04, now the force has been doubled, the extension needs to double. So I would have gone for 0.08, but let me still solve it using the standard procedure or the theory. So Hooke's law states that the force is directly proportional to the extension, provided the properties of the constant of the material remains constant. So which is K here. So considering the first instant, we are going to use the first instant to determine the spring constant. Spring constant will now be, if we make K the subject, now be F, in this case is W, because that's the first force, over E, that's the first force that was applied. So which is 8 divided by the extension, the initial extension was 0.04, and if you do that, you end up having 200 Newton per meter. That's the Newton per meter is the unit for spring constant. So we have gotten our constant. So what is left now is for us to calculate the extension when a force of F equals to 16 Newton is applied. So that will now be 16 equals to, our K is 200 times extension, the new extension. So extension will then be 16 divided by 200. Very, very simple. So that you have 0.08 meters. That's option D. So subscribe to the channel, and for online classes in real time, you join my WhatsApp group and book a session with me. Thank you.